Hello everyone, myself Prasanto Vikundu. I welcome you all to this lecture of soft computing techniques. This is the second lecture of module 10. We have understood graph membership functions, dependency of attributes. Dependency of attributes. An important issue in data is discovering dependencies between attributes. A set of attributes D depends totally on set of attributes C denoted as C imply D if all values of attributes from D are uniquely determined by values of attributes from C. In other words, D totally depends on C. If there exists a functional dependency between values of D and C. Formally, a functional dependency can be defined in the following way. Let D and C be subsets of A, will say that D depends on C in a degree k, where k is a number lies between 0 and 1, denoted C imply dk or C imply dk. If k equal to gamma cd, that is the cardinal number of positive region of the partition u by d with respect to attribute C, divided by total number of objects. So here is the this is the number of objects, and positive region is nothing but the union of all lower approximations of the equivalence class of u by d. So first of all, we'll calculate the indiscriminate relations u by d. Then if it is just like x1, x2, etc., so we'll find the all lower approximations, that is C lower approximation x1, C lower approximation x2, and so on. Then we'll take the union. So that will be the positive region of D partition u by d with respect to C. So that Kali number of that. So in this way we will calculate the GAM. Let's try to understand one example. So here we have a decision table where objects are P1, P2, P3, P4, P5, P6. Headache, muscle pain, temperature are the attributes, and this is the decision attribute. So you can say that the attribute, these are the three attributes are known as the C. This is decision attribute D, and attribute is set is C union D, and this is the objects. Patients are the objects. So that is a decision table. So here patients P1, headache no, muscle pain yes, temperature high, flu is yes. Similarly for P2, yes, muscle pain is no, temperature is high, flu is yes. P3, temperature is very high, muscle pain is yes, headache is yes, flu is yes. Similarly you can at P4, P5 and P6. So now try to find the lower approximations and upper approximation of the positive region. We'll try to find these things. So here see the attribute sets, which is headache, muscle pain and temperature. So find indiscriminate relations of C, that is U by C. So here P1, so P2 and P5 are the same thing. So here P2 yes no high, P5 yes no high. So they are the same thing. Rest all are different. So it is P1, P2, P5, P3, P4, P6. Indiscriminate relations of U by D, flu yes, so that is P1 flu yes for P1, P2, P3, P6 and the flu yes, and P4, P5 flu no. So here this is set is x1, this is x2. So x1 is P1, P2, P3, P6, x2 is P4, P5. So try to find the lower approximations of the attribute as C with respect to that U by D. So that is x1. So lower approximation. So here see that P1 is a subset of this. So P1 will be here. P3 is here. P6 is there. P2 will not be here as P5 is not belongs to the x1. So P2, P5 is not a subset of that. So we get only lower approximations P1, P3, P6. For x2, P5 also not there. So we will get only P4. So positive region is the union of all lower approximations. So that is P1, P3, P4, P6. So that is the positive region of the partition U by D with respect to C. So D depends on CD degree of K, denoted as C implied D. K is here. So that is K equal to the cardinal number of the positive region, that is 4, by total number of objects, that is 6. So it is here K equal to 4 by 6 is equal to 2 by 3. Similarly, if you take C attribute as temperature. So temperature is P1, P2, P5. So I check P1, P2, P5 is high, P3, P6 very high, and P4 is normal. So that is the U by C. Again, U by D, flu yes, flu, and this P4, P5 for flu no. So X1 is P1, P2, P3, P6, X2 is P4, P5. Now, if you take the subset of the temperature, so you will get here P1, P2, P5 will be not there. So here you will get only P3 and P6 because P1, P2 or P5 is not a subset of that. Here we get only P4 for X2. So here positive region is the union of all the lower approximations. So that is P3, P4, P6. So here K equal to 3 by total number of objects, that is 6. So it is 3 by 6, that is half. Similarly, if you consider headache, so that is P1, P4, P6, P2, P3, and this is X1, this is X2. So lower approximation is 5 because no one is subset of that. So P1, P4, P6 is not a subset of these things. P4 is not there. P2, P3, P5 not a subset because P2, P3 is not here. So lower approximations is 5. Similarly, here also P4, P5 nothing is subset of that, so that is the also 5. So positive reason is 5, so here k equal to 0. Now consider c equal to muscle pain. So here u by c is p1, p3, p4, p6, p2, p5. This is x1, this is x2. So see here p1, p3, so p4 is not here, again p4, and also this is also not here, so not here p2, p5. So for this x2 lower approximation also 5, so k equal to 0. So here 4 out of 6 patients can be uniquely classified as having flu or not, employing attributes headache, muscle pain and temperature. If we are interested in how exactly patient can be diagnosed using only the attribute temperature, that is in the degree of dependency, temperature imply flu, we would get k equal to 3 by 6, that is half. Since in this case only 3% P3, P4, P6 out of 6 can be uniquely classified as having flu. In contrast to previous case, patient P1 cannot be classified now as having flu or not. Hence, the single attribute temperature offers worse classification than the whole set of attributes headache, muscle pain, and temperature. It is interesting to observe that neither headache nor muscle pain can be used to recognize flu because for both dependencies, that is headache imply flu and muscle pain imply flu, we have k equal to 0. It can be easily seen that if T depends totally on C, then indiscriminate relation C subset of indiscriminate relation D. This means the partition generated by C is finer than the partition generated by D. Let us notice that the concept of dependency discussed above correspond to the considered in relational databases. Summing up, D is totally or partially dependent on C if employing C all elements of universe may be uniquely classified to the block of the partitions U by D. Now try to understand one more example. Let A is equal to the set of objects, that is U1, U2, U3, U4, U5, 6, 7, 8, and here also the attributes are degree, subject, birthplace, and D is the decision attribute, which is grade. So for one object, degree PhD, subject physics, birthplace D, grade is A. For 2, MSc chemistry, birthplace A, grade A. For 3, MSc physics, birthplace D, grade is C. For 4, degree BSc, subject mathematics, birthplace D, degree B. For 5, BSc chemistry, birthplace is A, degree C. Degree PhD, subject computer science, birthplace C, grade A. Degree BSc, subject chemistry, birthplace C, grade C. For degree, for 8 degree PhD, subject computer science, birthplace A, grade is A. So now try to understand the indiscriminate relations. So that is first U by degree, or that is indiscriminate of degree. So here 1, 6, 8, 2, 3, 1 PhD, 168 PhD, 23 MSc, 457 BSc. So that is U by C. Similarly, you can find intensity relation of subject. So subject is 1 3 for physics, chemistry is 2 5 7, then computer science, then math. So part plus also same thing, u 1 3 4 2 5 8 6 7, u by grade 1 2 6 8. So grade A is 1 2 6 8, grade B is 4 and 3 and 5 7 is 6, so that is 1 2 6 8. So here you can take that is x1, this is x2, this is x3. So consider C equal to degree, subject and birthplace, set of all attributes. So in descriptive relation C, that is u by C, you will find all are different. So that is 1 2 3 4 5 6 7 8. So let C1 equal to degree and subject. Basically C1 equal to total, that is degree, birthplace, subject minus birthplace, so we'll get degree and subject. So that is C1. So indiscriminate relations of u by C1, that is indiscriminate relation of C1, you will get 1 2 3 4 5 7 6 8. So you need to cancel omit birthplace, so that 5 and 7 is same. So birthplace same, so 5 and 7. Basic chemistry basic same. Similarly 6 8 are the same. Rest all are different. So we'll get the indiscriminate relations of the C2 or C1, uh, 1 2 3 4 5 7 same, 6 8 same. Similarly for C2 degree, birthplace, so C2 basically C total minus subject. So you'll get u by C2 is 1 2 3 4 5 6 7 8. C3 subject, birthplace, that is C3 को total minus degree. So you'll get 1 3 2 5 4 6 7 8. So uh, C3 C minus degree. So let's check once again, C minus degree. So degree on it, then you will get it 1 and 3 are same, 2 5 are the same, like that. So I hope you have understood the C1, C2, C3 and the indiscriminate relations of C1, C2 and C3. So as U by D, that is indiscriminate of grade, is grade A 1 2 6 8, then C, then B 4. So now for C, so C is total, so all are different. So 1 2 6 8, so that is C1. uh, C lower approximation with respect to x1 is all are different, so you'll get 1 2 6 8. For x2 all are different, so you'll get 3 5 7, x3 also 4. So positive is an union of all the lower approximations, so you'll get 1 2 3 4 5 6 7 8, union of all the lower approximations. For C1, so here x1 is 1 2 6 8. Now in this particular sum C1, C1 is 5 7 and 6 8. So 1 2 3 are different, so here you can write the indiscriminate relation of C1. So let's write the indiscriminate relations of C1 first. So indiscriminate relations of C1, that is u by C1. So that you take from here, so that is basically 1 2 3 4 5 7 6 8. So 1 2 3 4 5 7 6 8. So that is x1, this is x1, this is x2. So now here 1 2 6 8, and for x2 is 3 5 7. So 3 5 7, for x3 is 4. So here also you get 1 2 3 4 5 6 7 8. So that is the union of all lower approximations. For C2 lower approximations, for C2 x1 is 1 2 6 8. Then also here 1 3 5 7, it was 4. So here we get positive region of u by d with respect to C2. It is 1 2 3 5 1 2 3 4 5 6 7 8. Now try to write the eigenidentity relations of C3, that is u by C3. So write it first, then we'll check it. So C3 is 1 3 2 5, rest all are different. 1 3 2 5 and the rest all are different, so that is 4 6 7 8. So this x1 is 1 2 6 8. So here 1 3 will be not there, only 6 8 is there. 3 5 7, so x3 is 3 5 7 will be not there, so only 7 is there. For x3 4 4 is there, so I will get 4 6 7 8. So here positive region of C, is equal to the positive regions with respect to C1 is also positive with respect to C2. These two are equal, but positive region of U by D with respect to C is not equal to the positive region of U by D with respect to C3. So this is not equal. Now try to understand the concept. So let S equal to the set of objects, so that is U attributes and decision be a decision table. Let A be an attribute in C. Attribute A is dispensable, that is not required. This is not necessary. In S, if positive region of U by D with respect to C is equal to the positive region of U by D with respect to C minus A. Otherwise, if it is not equal, then you can say that the attribute A is indispensable. So C3 means C minus degree, so degree is indispensable. So rest two are dispensable. So a subset R of C is a reduct of C if positive region of U by D with respect to R is equal to the positive region of D of U by D with respect to C. So here reduct is C1 and C2. So C1 means what? C1 means that C1 means degree and subject, C2 means degree and birthplace. So C1 means degree and subject, C2 means degree and birthplace. So you can check it. C2 means degree and birthplace, C1 is that and C3 is not that. So here you can say that C1, C2 are the reduct of C because here these two are equal. These two are equal. So, and if the table is S1, U R U union D is independent, that is all attributes in R are indispensable in S1. So core of C is the set of attributes shared by all reducts of C. So core C equal to the intersection of reduct and C. So here you can find the intersection is the degree. So where reduct C is the set of all reducts of C. Here C1, C2 are the reducts of C. C3 is not a reduct of C, and the core of C is degree. So we'll solve few more examples on this topic. So in conclusion, so here what we want to make any table. So here we make any a table which is the objects A, B, C, D, E, F are the objects. Attributes A1, A2, A3 and D is the decision attributes. So you can write the value of A1 is 1, 1, 2, 3, 2, 3. 2 is 4, 5, 4, 6, 4, 5. Here also 7, 8, 7, 7, 8, 7, D, Y, N, Y, Y, N, Y, N, like that. So try to find the all the things like take C equal to A1, A2, A3. Then find the positive region of U by D with respect to C. Then find take C1 which is take A1, A2, take then you find positive region of C1 with respect to U by D. Take C2, A1, A3, then find positive region of C2 with respect to U by D. Then you take C3, find positive region of C3 with respect to U by D, where C3 is equal to A1, A2 and A3. Then try to understand the what is the reduct and core, etc. So these are the reference of today's class. Thank you.